Okay, continuing on. So we were looking at else-if statements, and now we're going to go on to 12. Okay, review for control flow. So all of these topics, Boolean expressions, the relational operators, the equals, the not equals, the not Boolean operator, the if, the else if, the else, all of this is part of this idea of control flow. So flow is like the flow of logic, I presume. You know, the flow of what we decide to do based on what we know. So if such and such is the case, then we do this. It's called control flow. Great job. We've covered a ton of material in this lesson, and we've increased the number of tools in our Python toolkit by several-fold. Let's review what we've learned this lesson. Boolean expressions are statements. They are another example of a statement, but not all statements are Boolean expressions. They are statements that can be either true or false. A Boolean variable is a variable that's set to either true or false. Literally true, literally false. These are kind of a Boolean expression we might say is indirectly true. It collapses down into true or false because it might be an expression like 5 is greater than 9. We can create Boolean expressions using these relational operators. Equals, not equals, greater than is a relational operator, greater than or equal to, less than or less than or equal to. If statements can be used to create control flow in your code. Else statements can be used to execute code when the conditions of an if statement are not met, and elif statements can be used to build additional checks into your if statements. Let's put these skills to the test. Instructions. Optional. Little Cody is an interplanetary space boxer who is trying to win championship belts for various weight categories on other planets within the solar system. Write a space.py program that helps Cody keep track of their target weight by 1. Checking which number planet is equal to. 2. Computing Cody's weight on the destination planet. Okay, 1. Checking which number planet is equal to, and 2. Computing Cody's weight on the destination planet. Okay, so presumably this is someone who goes to these different planets and things change on the different planets. So here we have a table. We've got a list of planets. We have Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. And then we have this term relative gravity. So the relative gravity on Venus is 0.91. On Mars it's 0.38. Saturn 1.06, so sometimes it's greater than 1, sometimes it's greater than 2 if we look at Jupiter. Okay, so that's the task. Right, you see, it's much bit of a broader task this time. Write a space.py program that helps Cody keep track of their target weight by checking which number planet is equal to and computing Cody's weight on the destination planet. So we might say if planet is equal to Venus, then print is when they say, just this is a bit of a point, a bit of a subtle point, but weight takes into account your mass and the relative gravity. So am I expected to do that? I mean, if we're talking about physics, relative gravity is not what weight is, but 2 is compute Cody's weight on the destination planet. Maybe I could just say if the planet equals Venus, then print the relative gravity. Oh, okay. So we have a variable weight is 185 assigned to it, and planet equals 3. So we need the program to keep track of the target weight by checking which number planet is equal to, checking which number 3 is equal to. I'm not sure. I'm not. If planet is equal to 3, then print your weight is 185. Checking which number planet is equal to. What do you mean checking? You mean just saying if it's equal to... Do we have to think about every number it could possibly be? I'm not sure this is very well designed. Click to see a hint. To compute their weight on the planet they are fighting on, multiply their Earth weight and the relative gravity on that planet. Okay. So if the planet is equal to 3, then what we'd need to do is 185 multiplied by the... But I don't know what 3 is. I don't know what the... Oh, okay, that's the number column. So 3 is Jupiter. So if planet equals 3, then we do 100. Then we'll do weight multiplied by Jupiter 2.34, which is the relative gravity on Jupiter. And in fact, we could print that. We could say print your weight, print a string which says your weight is and then your weight is and then weight, yeah. Could we do that? No. Okay, hold on. Okay, so here's the solution. If planet equals 1, weight will assign to weight multiplied by 0.91. Else, if planet is equal to 2, weight will assign to that weight multiplied by 0.38. Okay, so they do want us to kind of manually go through and say, if the planet is 1, use this value for the relative gravity. Else if. So manually do it for all the planets. We were on the right track in doing weight, having just this weight variable and multiplying it by 2.34. It's just that we didn't account for all the other planets. You know, the reason I did that though is because here it says planet equals free. Why have they put that in? So that really confused me. Okay. So if I'm going to reset the workspace. So this is what we're given. Weight equals 185, planet equals free. And it says, and we have a comment here which is write an if statement below. So what they want us to do is go if the planet variable happens to be 1, then weight will assign to weight itself multiplied by, okay, so you can do that. You can say weight as assigned to it and then itself. Weight equals weight multiplied by 0.91, which is the value of the relative gravity for planet 1. And we don't do if again, remember, but we could do, you know, in this situation we could do, because it's okay if we have all these sort of independently, but you can also do it as else if planet equal. What it is we don't have a sort of continuous value. Like if you imagine a situation where people donate money on a charity website, and we want, if the donation is above £1,000, we want to say thank you, you're a platinum donor. If it's bigger than just £500, we want to say thank you, you're a silver donor. Then we'd use else if, because that's a continuous range. Money is like a continuous range. It could be 500, 1,000, and the condition which we specify, okay, greater than 500 means give silver. Well, if you gave £10,000, that's more than a 500, isn't it? But you don't want to say to them you're a silver platinum, because you want to kind of have it to be a sequential going through the conditions. Else if planet equals to, so my point is we could use if here, then the weight will be equal to the weight multiplied by 0.38. So that's planet equals 2. Elif planet equals 3 colon weight will assign to weight itself multiplied by 2.34. Elif planet equals 4. weight will assign to weight multiplied by 1.06. Elif planet equals 5. Weight has assigned to it itself multiplied by 0.92, was it? Yeah. And if planet equals 6. Weight equals itself. Weight is equal to weight multiplied by 1.19. And the final line, print your weight, colon, comma, weight. So that is right. We can put a variable in there. I still don't know if we can put in a what? Oh, is that indented? Oh. 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 That's better. Okay. I found the instructions to this very confusing. If you look at what it actually says, it says Little Cody is an interplanetary space boxer. Write a space.py program that helps Cody keep track of their target weight. And that cannot be indented. Okay. Try that. Okay. By checking which number planet is equal to, and computing Cody's weight on a destination planet. And it just confused me whether we had to, the fact that they have set planet to 3. I mean, this is an interesting way of saying we're going to account for all the different planet possibilities, because that's what we've done. We've said we've accounted for the situation in which planet is 1, planet's 2, planet's 3. We've accounted for every possibility. And they've said, well, what we're doing there is checking which number planet is equal to. I suppose we are. That's not how I'd put it. I'd say account for every possible value planet can take. Anyway. Okay, next. Lesson complete. You earn 25 XP each toward your skills. Match statements in Python. Learn how to declare and use match case statements in Python. Like the if-else statements, we can also use switch statements to build a program's control flow. In Python, we have match case statements that implement switch statements. Let us discuss switch and match statements, how to define them in a Python program, and when to use match case statements instead of if-else statements to build control flow in a program. What is a switch statement? A switch statement is a control flow statement that executes a block of code, among many others, based on the value of a variable or expression. That's a switch statement. Functionally, switch case statements are almost like if-else statements. For example, let's look at the code from the if statements exercise. Username has assigned to it the value Dave as a string. If username is Dave, print get off my computer Dave, see here. Else, if username is Angela Cat Lady, print I know it's you Dave, go away. Else, if username is Codecademy, print access granted. And then else, print username not recognized. The above code can be written using a switch statement, as shown in the following code. Don't worry about the syntax, it's explained in the next section, so let's take our time with this. So username has assigned to it Dave, and then we have this keyword which is switch username, and then all of this text is below and indented, so we say switch username colon case Dave colon print get off my computer Dave case Angela Cat Lady 87 colon print I know it is you Daniel, go away. Case Codecademy print access granted. Case default print username not recognized. So you see it's similar in some ways to the code we've kind of already seen. We have a kind of if statement, and then we'd have indented below the stuff we want to do, the consequent, if the condition is satisfied. So we'd print in each of these 3 different situations, and we have a colon before we introduce the consequence. So colon, and then what we want to do, colon, and then what we want to do, colon, and then what we want to do, colon, and then what we want to do. But of course, there are so many differences. Here we just have case. There's no if anywhere in sight. It's CASE space, and then we just put in speech marks the value. So it kind of knows that we're talking about the values of the variable. So switch username, it's as if this line is saying, what if we were to switch out the value that username has? So this first line says username has assigned to it Dave, and this line is saying, well, what if we were to switch out username, or what if we were to switch out the value that username has for something else? What if we were to switch it out? What about the case in which we switch it out for Dave? What about the case in which we switch it out so that it says Angela Cat Lady 87, which is different from its current value Dave? What about the case in which we make the value Codecademy? Well, in that case, it would be different from Dave. We'd print access granted then. And then we can do case default. And you can see that the word default is in orange. And that means it's a keyword, presumably. It's kind of part of the program. So Codecademy, that string is in yellow. Dave, that string is in yellow. But if we do the final case default, well, of course, this part is a bit like the blanket statement, or the blanket situation, where we have the else statement. If you run the above code, it will encounter a syntax error because Python does not have a switch keyword. Oh. Python didn't have switch statements or any of its implementations until version 3.10. In Python 3.10, right, so remember that version, that's an important version. In Python 3.10, we got match case statements that implement switch statements and other functionalities. From now on, we will refer to switch case statements as match case statements, as defined in Python. So we're not going to talk about switch case statements, we're just going to talk about match case statements. How to declare a match statement in Python. We use the match, case, and default keywords to define match case statements in Python. It has the following syntax. Match, the word match, and then we'd have an expression, and then a colon. Case, value 1, colon. Case, value 2, colon. Case, value 3, colon. Case, value 4, colon. Okay. So instead of the word switch, we just have the word match. Now in the above code, match is a keyword that marks the start of the match block. Okay, so this word here, match, is a keyword and it just marks the beginning of the whole match block. Expression can be a variable, an arithmetic expression, or Boolean expression, or a Python object like a list, tuple, or string. So a string is a Python object, a list is a Python object. So here we say match, it's just marking the beginning of the match block, and an expression, that can be many things. It can be a variable, so we can have the word match, then a variable. We can have the word match, and then an arithmetic expression. We can have the word match and then a Boolean expression. The code inside a case block is executed for a single value of expression. For example, only if expression evaluates to value 1 will the code inside the case value 1 block be executed. So here we have case value 1, this is the case value 1 block. Well, we're only going to execute this if the expression does evaluate to value 1, or has the value of value 1. If expression evaluates to value 2, then only the code inside the case value 2 block will be executed. Only one case block is executed in the entire match block for any given value of expression. Once the case block is executed, the program's control flow moves out of the match block. The default block is always present at the end of the match block. If expression matches none of the values in other case blocks, the code inside case default is executed. Using the above syntax, we can rewrite the code given in the switch case example, as shown below. So we don't want to use switch case, we talk about match case. So we would say username to declare a variable, and we'll assign it a value, and we'll give it a string. So we've put Dave in speech marks. So username, we'll assign to username Dave. And then we can use the match keyword, match username. So you just invoke that variable name, match space username, colon, case Dave, print this, case Angela Cat Lady, print this, case Code Academy, print this, case default, print this. So it's match case syntaxes. If you run the above code, you will get the following output. Get off my computer, Dave. When to use match statements in Python. We can use match case statements for the following use cases. Match case statements can be an efficient alternative to if, elif, else statements. When a variable or expression can take multiple values and we need to perform a different action for each possible value, we can use match statements. A match case block can be used for other tasks like structural pattern matching, in addition to replacing if-else blocks. This helps us check for different conditions on Python objects like lists, tuples, and strings. Match case statements are more readable compared to if, elif, else statements. Hence, in cases where we must check for many values that an expression or variable can take, we should use match case statements. Article complete. You earned 10 XP each toward your skills. We have a Python skill on the go, and we're now at 200 XP, and we have a computer science skill on the go, and we're now at 200 XP. Join the Python Club. Don't miss out on the chance to connect with learners just like you. Join a career or city club that is carefully curated by club captains. Let coding together propel your learning. Find focus. Connect on your shared interests in Python. Attend live events. Meet experts, ask questions, and learn in real time. Collaborate. Enhance your skills through the power of teamwork. By selecting Join Club, you agree to Circle's Terms of Service and Privacy Policy. You'll be directed to community.codeacademy.com, powered by Circle. Okay. You know, do a new post here in the London Club. 657 members. Events. Okay. Moving on. Determine the truth value of the following expression. Which of the following variables contains a Boolean value? Read the following code carefully. What will happen when the code is executed? X has assigned to it a value of 0. If X has assigned to it 0, that should probably perhaps be an equals operator. Print X is equal to 0. If X is greater than or equal to 0, print X is greater than 0, else print X is less than 0. But there'll be a syntax error. It will cause a syntax error because that character is not a relational operator. To fix the code, that character should be replaced with the double equals sign. Which of the following is a Boolean expression? The New York Yankees are the classiest baseball team. Dogs are the best pets. My name is Angelo. 3 is the most elegant number. Consider the code below. What would this print to the terminal? X has assigned to it 5. If X is smaller than or equal to 2, print this is printed. If X is smaller than or equal to 4, print this is also printed. If X is smaller than or equal to 6, print is this printed. And if X is smaller than or equal to 8, print this might be printed. So because it's 5, well, it is smaller than or equal to 6. So we're going to have is this printed, and we're going to have this might be printed because it is smaller than 8. So is this printed, and this might be printed. It's not smaller than 4, and it's not 2. Correct. Determine the truth value of the following expression. 4 multiplied by 5, which is 20, is less than or equal to 21 take away 1. Well, it is equal to that. 21 take away 1 is 20. 4 multiplied by 5 is 20. 20 is equal to 20. So that is true. Determine the truth value of the following expression. 9 take away 4, which is 5, multiplied by 2, which is 10. So that's 5 multiplied by 2, which is 10. 10 is equal to 77 divided by 7 take away 1. Or is it 77 divided by 7 take away 1? Well, here we have a procedure, a priority system. I think it's called PEDMAS. Parentheses come first, then exponentiation, then PEDMAS, then division. So I think it might be 77 divided by 7, which is 11, divided, take away 1, so 10. So is 10 equal to 10? True. Phew, that is true. Determine the truth value of the following expression. 3 to the power of 2, and you might think, well, isn't it 3 to the power of 2 plus 1? No, because exponentiation is very high up on the priority list, so that is a tight binding. The scope of this is very exclusive, so it only reaches to this. That 2 gets raised, not all of this expression. So 3 to the power of 2 is 9, 3 squared is 9, plus 1 is 10. Is 10 not equal to 30 over 3? Or 10? Is 10 not equal to 10? False. It is equal to itself. It is equal to 10, so false. Control flow. Perfect. Your highest score, 100%. And you can review your answers. So we had that question. We had this question. Continue learning. Magic 8 Ball. We've learned about and explored a powerful tool in Python, control flow. It's so powerful, in fact, that it can be used to tell someone's fortune. Here's what to expect. Check off the project tasks as you complete each one. This is not an exam, so you can refer to other resources to help you complete the project. And now you can get AI-generated hints when you need help to complete a task. The Magic 8 Ball is a popular toy developed in the 1950s for fortune-telling or advice-seeking. Write a magic8.py Python program that can answer any yes or no question with a different fortune each time it executes. We'll be using the following 9 possible answers for our Magic 8 Ball. Yes, definitely. It is decidedly so. Without a doubt. Reply hazy. Try again. Ask again later. Better not tell you now. My sources say no. Outlook not so good. Very doubtful. So they're the 8 possible answers. The output of the program will have the following format. Name asks, and then the question. Magic 8 Ball's answer, colon, and then the answer. For example, Joe asks, is this real life? Magic 8 Ball's answer, better not tell you now. Let's get started. So in magic8.py, declare a variable name and assign it to the name of the person who will be using the Magic 8 Ball. Okay, I'll put Jeff. But I really don't like that sloppy language. We don't assign variables, we assign the value of the person's name to the variable. We're not assigning the variable to the name, we're assigning the name to the variable. Okay. Next, declare a variable question and assign it to a yes or no question you'd like to ask the Magic 8 Ball. So, question. Will I win the lottery next week? We want to store the answer of the Magic 8 Ball in another variable, which we'll call answer. For now, assign this variable to an empty string. So answer, we'll just do like that. Generating a random number. In order for the answer to be different each time we run the program, we will utilize randomly generated values. Note, this will be something new, but don't worry, we will try to explain this topic thoroughly and also supply the code. In Python, we can use the .randint, random integer function, from the random module to generate a random number from a range. But first, let's import this module so we can use its functions. Add this line of code to the top of magic8.py. So we have to go to the top of our code and say import random. Task 5. Next, we'll create a variable to store the randomly generated value. Declare a variable called random number and assign it to the function call. Again, have assigned to it the function call is what they mean to say. So random number, and we'll assign to it random dot, so you see we're calling the thing we imported. So random number, we'll assign to it random dot rand int, short for random integer, and then we'll put in rounded brackets 1, 9. So again, random dot rand int 1, 9. And this will generate a random number between 1 and 9, and it's inclusive, which just means that we include the actual bounds. So it could be 1 itself or 9 itself. Next, add a print statement that outputs the value of random number, and run the program several times to ensure random values are being generated as expected. So we can just say print, and we'll put the name of the variable. Print random number, random number. So you can see we have 4, 3, 6, 1, and so on. Once you're sure this is working as we expected, feel free to comment out this print statement. And now it won't work. Good. Task 6. Now that we've declared all the variables needed, it's time to implement the core logic of our program. For this section, we'll be utilizing control flow using an if, elif, else statement to assign different answers for each randomly generated variable. First, write an if statement where if the random number is equal to 1, answer is assigned to has assigned to it the phrase yes definitely. So if random number is equal to 1, then answer will have assigned to it yes definitely. I think that's correct. Task 7. Next, write an elif statement after the if statement, where the random number is equal to 2. So elif random number is equal to 2. What? Answer has assigned to it the phrase it is decidedly so. Then continue writing elif statements for each of the remaining phrases for the values 3 to 9. Okay, so elif random number is 3. Answer will have assigned to it without a doubt. Elif random number has assigned to it 4. Answer will be reply hazy, try again. Elif random number equals 5. Answer equals ask again later. Elif See, I'm not going to use else there. Yeah, I don't, because we shouldn't. Yeah, okay. Oh, you see, slipped out of it there. Equals 6, equals 7, equals 8, equals 9. Okay. Task 8. Follow the if-elif statements. Add an else statement that will set answer to the string error if the number was accidentally assigned a value outside of our range. So we can say, fucking thing, yeah, control and enter, I understand. Control and enter. Can you move that bubble now? No? Right. Else answer is equal to, or has assigned to it, the string error. Okay. I don't know why, if you look at the answer, it should just be one indentation in. So just get that in. Cool. Seeing the result. Task 9. Now let's see our program in action. Write a print statement to output the asker's name and their question, which should be in the following format. Name asks question. So up here we've assigned them a name and assigned them a question. And we can say print this string. So name plus asks, and then add the question. I think we can do that. So name is the variable up here, so I can just mention that, invoke that, and then I'll say asks as a string, and then question. Again, question is the name of the variable that I have up here. Save that. Okay, so Jeff asks, and actually I might want to add a colon there so that it's like clear where the question begins. So Jeff asks, will I win the lottery next week? Cool. Task 10. Add a second print statement that will output the Magic 8 Balls answer in the following format. Magic 8 Balls answer, colon, answer. So print, and I just put the opening rounded bracket, Magic 8 dash balls, Magic 8 Balls answer, colon, and then that plus operator for concatenation of strings, and then I'm going to bring in the answer variable. For example, when running the program, it should look something like this. Magic 8 Balls answer, my sources say no. So save, brilliant. So reply hazy, try again. And if I refresh it, it should come back with a different answer. Is it decidedly so? Ask again later. It is decidedly so. Ask again later. Without a doubt. Perfect. So what's happening is, the reason is we're coming back with different answers is we're running this random integer function, which is part of the random module, which gets put into random number, and then we're acting on that randomness and coming back with the different phrases. Task 11. Great job, you've successfully utilised your knowledge of conditionals and previous fundamental Python concepts to create a program that generates different fortunes. Run your program several times to see that it's working as expected. But I think we have, so I'll give that a tick. And we're going to stop there.